Hello everyone, welcome to my YouTube channel, A Physics Asylum. I am your Gaurav sir and our today's topic is Coulomb's law in vector form. So let's start with this topic. सबसे पहले कूलॉम्स लॉ को वेक्टर फॉर्म में पढ़ने के लिए हमने जो है वो एक कार्टेशियन कोऑर्डिनेट क्रिएट किया. This is your x-axis, y-axis and z-axis. कूलॉम्स लॉ क्या था? टू चार्जेस के बीच में लगने वाला फोर्स ऑफ अट्रैक्शन या फिर फोर्स ऑफ रिपल्सन. ठीक है, तो यहाँ पे सबसे पहले हम क्या कंसीडर कर रहे हैं? दो चार्जेस को कंसीडर कर ले रहे हैं. तो सपोज दिस इज चार्ज q1 एंड दिस इज चार्ज q2. डन. नेक्स्ट, this is our origin. Let us assume that the charge q1 be placed at a distance r1 from the origin and charge q2 be placed at position r2 from q2. Done. Next, from q1 to q2, if we move from q1 to q2, then the resultant of this vector is r12. Done. So here if we move from q2 to q1, then this distance will be r21. Now here two charges q1 and q2 both have positive. So in between their charges there is a force of repulsion because both the charges has same sign. So the force on q1 due to charge q2 is F1 due to 2. The force on q1 charge due to charge q2 is F12 vector. Similarly, if q1 applied the force on q2, then this is also the force of repulsion and it will be F21 vector. Got it? Force by q2 vector is F21 and force on q1 vector due to q2 vector is F12. Both have same magnitude, that is why they are repel each other. Done. Next step, we know that we have a Coulomb's law. What can we say about the Coulomb's law? The Coulomb's law said that if there are two charges placed across a finite distance, then the force of attraction between both the charges is directly proportional to the product of their magnitude and inversely proportional to the square of distance between them. Okay, so let's apply Coulomb's law on these charges. Now from Coulomb's law, from Coulomb's law, F12 vector, this vector F12 is equal to K multiplied by magnitude of both charges. So here Q1 and Q2 divided by the distance between them. So the force of attraction will be Q2 to Q1. So the distance between Q1 and Q2 is taken R21. Whole square. Here we mentioned the direction. So along R21 vector. Now we know that in any vector quantity, the unit vector define the direction of that vector. So here in this forces we can also mention it F12 vector is equal to K Q1 Q2 divided by R21 vector square. Here in direction we can write R21 cap. R21 will gives the value of R21 cap is equal to R21 vector divided by mod of R21. This is the formula of calculating a unit vector. Now here we can write F12 vector equal to K Q1 Q2 divided by here R21 square multiplied by R21 vector divided by mod of R21. That is why the whole vector is K is equal F is equal to K Q1 Q2 divided by R21 का Q and here R21 vector. This is the Coulomb's law in vector form for force F12. Done? Force F12. Similarly, we can write it whole for vector F21. So, what is the conclusion? The conclusion is, I can write it here. Similarly, F21 vector is equal to K Q1 Q2 divided by R12 whole cube R12 vector. This is the formula of force F12 and this is the formula of force F21. From both the formula we can write a conclusion. Here we can see that F12 vector is equal to minus of F21 vector. How can we say that this? How can we say that this F12 vector equal to minus F21 vector? So, how can we say that F12 vector is negative of F21 vector? Let's see this figure. Here we know that from triangle law of vector addition. What is triangle law? What is triangle law of vector addition? The triangle law of vector addition said that here vector is starting from O to Q2 and this is with the direction of vector R21, R2, R2, R21 and R1. So the resultant of these two vectors is R1 vector. So we can write it R2 vector in the direction of vector R21 vector in the direction of vector, because this is tail and this is head joined by tail of another vector. So this will be in the same direction. So R2 vector plus R21 vector is equal to R1 vector. We can say that this. Now here R21 vector is equal to R1 vector minus R2 vector. Similarly, if we write from R1 vector to this and this, then we can write from R1 vector plus in the direction of R12 vector equal to resultant R2 vector. So we can write it R12 vector equal to R2 vector minus R1 vector. Then now if we see this equation and this equation, then we can write, if we common negative sign from here, then we can write R21 vector is equal to R1 vector minus R2 vector. And what is this? R1 minus R2 is equal to R21 vector. So we can write R21 vector is equal to minus of R12 vector. From this conclusion, if we put it from the Coulomb's law of force, then we can say that F21 vector is also equal to minus of F12 vector. This is the Coulomb's law in vector form. Okay, done.